What's up, YouTube? Thanks for joining. I'm Chris Dindy. I'm a technical consultant on HPE Aruba Networking's Proof of Concept team. Today, we're going to be talking about a powerful new feature in the Aruba CX switching portfolio that's called Application Recognition and Control, with one of its practical uses, application-based policy. These features, when used together, give you the ability to enhance network visibility, make performance improvements, and bolster security right at the edge. So today we're going to start with an overview, then we'll move into the key benefits that application recognition and application-based policy provide for you as a network administrator and for your network security policies. Then we're going to look at the prerequisites and caveats that are good to know in getting this feature up and running properly. We'll go over the order of operations in getting this feature set up and configured. And then we'll conclude with a demo where I'm going to show you what the configuration process actually looks like, and then I'll show you from an end user perspective what it looks like when an application-based policy is applied. So first and foremost, what is application recognition and control? This has been a long-standing feature in the Aruba portfolio where for years now we've been able to tunnel traffic back to one of our gateways to apply a deep packet inspection DPI engine along with a stateful firewall. And in the past, we were even able to do that with wired traffic, where we could do user-based tunneling and send our wired traffic directly back to the wireless gateway, or excuse me, just the gateway, in order to be able to send it through that same DPI engine and stateful firewall. This is a great feature and provides a unified experience for users regardless of how they connect to the network, whether it's wired or wireless, and still has a lot of practical use cases. But ARC simplifies this process and moves visibility right to the edge of the network. And with that, we're able to then take a unique action based upon what's being defined within our policies. So deep packet inspection at the network edge has been a feature that we've offered for a significant amount of time with user-based tunneling, but it does have limitations. As I mentioned, it requires the addition of our Aruba gateways, and user-based tunneling is a little bit more of a complex configuration to get that traffic back there. And within that, there is no provision, there's no support for east-west traffic analysis or for non-UBT wired traffic analysis. So this makes the legacy centralized model that we've used for so long a little bit more expensive with the addition of gateways and bandwidth intensive by creating a single egress point for all of your tunneled traffic. The new model that we're proposing moves that DPI engine and IP fix right to the access layer. And then we resolve the problems of east-west traffic analysis and non-UBT traffic analysis for our wired application visibility. So this feature has long been in the wheelhouse of Aruba. However, this new generation is even continuing to evolve extensively over the last few iterations of Aruba CX code. This was introduced in 10.11 with the basic functionality of being able to identify applications on switch and add the app ID to the flow tables. Then in 10.12 it became actionable when we got application-based policy, which could be defined within a local user role, centrally maintained in a downloadable user role in ClearPass, a device profile, or configured directly onto an interface. And this first iteration only had the ability to permit or drop an application or application category. So in 10.13, this feature set became more fleshed out with the ability to either mirror, set a local priority, or to DSCP remark this for QoS prioritization. And then in 10.14, we have the introduction of fast mode, which increases the number of connections per second by 25%. Which is significant, making it less resource intensive per application, but this does limit the information that's collected into the IP flows table, and it may not work as well behind a proxy. So let's look at the key benefits here. And that is to bring visibility and security to the edge. And this is accomplished through 4 key enhancements. First and foremost, the visibility. Beyond knowing what devices are on the network, it's important to know what those devices are doing. Application visibility provides a comprehensive view into traffic flows in an actionable way. And then once you know what traffic is on the network, admins are able to intelligently create effective policies to secure the network and optimize those traffic flows. Enforcement of these application-based policies can be done on a per-user role basis, which means you can give differential access to someone, say, in research and development versus a call center employee, or between a contractor and a guest. So this enables you to either make your network as custom tailored to individual users, or these policies can be leveraged across multiple roles, giving you the flexibility and creativity to make the network do what you need it to do for your business. And then finally, with application-based policy, we're able to dynamically remark QoS DSCP values based upon the application or application category, making sure that your mission critical applications get the bandwidth that they need and the network isn't starving because of undesired traffic on the network. And just like everything else in networking, the details really matter. So here are some prerequisites and caveats that you need to be aware of and consider when you're setting up ARC and ABP to really get this to work for you. So right now, application-based recognition is only supported on the Aruba CX 6300 and 6400 V2 switch. So in my demo, I'll be using the 6300, so you'll see those. We also require that the switches will be licensed with an advanced feature pack, or if you're using HPE Aruba Networking Central, then an advanced switch license is required. So the application recognition is stored within the IP flow tables, so we have to free up some of the resources in that by using the IP source lockdown resource extended mode command. You'll see that in the next screen when we're going, or excuse me, in 2 screens whenever we're going over the configuration. We have to enable flow tracking so that we can start populating those flow tables. And then we have to enable application recognition both at the global level and then lower down in the configuration, either at an interface or through a user role. And then the final caveat that I really want to cover is that you have to match your user role with a group-based policy role ID that connects the policies with the role and allows that to be functional. So the last thing I really want to point out is where we should be applying this. This is a feature designed for end user ports and can be configured directly on an end user interface or stored within a user role, whether that's local or downloaded, and should be only applied to those end user roles. We don't want to apply this to uplinks, downlinks, or interfaces connected to access points, as that could create a flood within the IP flows table of application recognition and consume unnecessary resources that can be better utilized elsewhere. So now that we've covered the basics, let's dig into the order of operations and how we actually get this set up and running. I like practical things, so let's look at that. First, if you're using an Aruba CX 6400 version 2 switch, ensure that you've set the profile to default to version 2. As I said, for my demo, I'll be using the 6300, so this step won't be done and won't be necessary. First thing you want to do is free up those resources of the IP flow table with the no IP source lockdown resource extended. Then we're going to enable flow tracking globally so that we can start populating that flow table. Then we're going to tell it what we're going to populate that table with and enable application recognition and control. And then we're going to tell application recognition control where to be applied at, whether that's at an interface level or at the user role. In our demo, we're going to be using the local user roles for configuration. As I mentioned, we do have to map this to a group-based policy. So here in this example, you can see it's been associated with the role ID 100. So now applications are being collected into the flows table. You can see categories. I'll show you what those flow tables look like a little later on in the demo. But now that we have that information, we can start designing our classifiers and policies for what's actually on our network. So we're seeing real-time traffic and we're able to make intelligent policy decisions based upon that. So this works like any other policy. You're going to configure your classifiers first, where you tell what type of traffic we want to match on, whether that's an application category or a specific application. We're going to match it, and you can see I've appended those with the count flag so that our hit counters will increment. And then after we define our classifiers, what type of traffic we want to find, we're going to create a policy to tell it what to do with that traffic. So in this situation, we've got some sample policies set up, but we'll use something a little bit more functional and robust in the demo. And then finally, now that we've defined that policy, we want to associate that with the role so that the switch knows where to apply this policy. And I do want to make one last note that as of AOS CX 10.14, for application-based policy to function properly, you may need to disable the quick protocol in both Edge and Chrome. Those are the browsers that I tested with. And those features, that is a feature that is enabled by default. However, not all applications utilize the quick protocol. So depending on what traffic you are actually trying to enforce a policy on, you may or may not need to disable the quick protocol. Let's go ahead and shift gears and jump into a demo. I'll be right back. My camera's going to go away, but I'll be with you going through the actual CLI configuration of this. And I've logged into my switch, and I'll show you I have a basic running configuration built that has radius with .1x and Mac auth against ClearPass, with ClearPass only returning the local user role VSA so that gets assigned dynamically to each switch port as a user authenticates against it. I have two basic roles configured right now, with the contractor role and then the employee role, and each one of them just has a basic description, a authentication mode, a spanning tree configuration, a reauth period, and their VLAN assignments, which dynamically get configured when this role is assigned to a particular client. So you can see within those roles, I don't have app recognition or an application-based policy, so I'm going to walk you through the configuration for each one of those. So let's start with clearing the screen. So the first thing I'm going to do is go into config mode and disable IP source lockdown, resource extended version, in order to free up our flow tables. And now I'm going to go ahead and enable flow tracking. And I'm going to populate the flow tables with our app recognition. And now I'm going to go in and actually assign that to the user role contractor. So now that that's been added to the role, whenever a contractor logs onto the network, we're going to see the flow tables populated with their application information. So I'm going to jump over to a client now, and I'm going to generate some web traffic, and we're going to see what those flow tables actually look like. So I'm logging in as my contractor, and I've got some traffic pulled up, but I'm going to just do a couple refreshes on everything so that we can see those flow tables as they're going. We just want to populate it. We've got our favorite Airheads broadcasting channel up. We've got Aruba Networks, and we've got some social media and some retail as well. So now that we've refreshed those, let's jump back over to the switch and see what those flow tables look like. You can see we've got a lot of traffic here. And we get a good bit of information with source and destination IP, source and destination port, protocols, what VRF it's associated with, an app ID, and then in the last two categories we see app name and app category, which is the information that we can use and leverage in our classifiers and policies so that we can enforce rules on individual user roles. So now let's actually look at the formation of those classifiers and policies. So again, let's clear our screen and exit out. so that we have a clear start so that we can work on our policies. So our IT team just received a mandate that contractors can no longer access retail, streaming, but they need good quality of service on their Teams calls. And one thing that's important to note is that our policies have a explicit deny at the end of them. So that we're not blocking all traffic, we're going to add an explicit allow at the end of our policy so that all of the applications that we are not making a policy rule on will still be allowed. So let's start with building our classes for our retail shopping. So this is a classifier, application-based policy, IP type, and we're going to call it retail. And we're going to give our sequence number. We're going to instruct it to match on TCP any source, any destination within the app category of web and the application of Amazon. And we're going to add that account addendum to that so that our hit counters will increment. Then let's go ahead and block the ad system as well. So we're going to do that to match on any protocol, any source, any destination, any app category, and the app is going to be Amazon ad system, and we want to count that one as well. All right, so now let's get out of there and let's do our streaming class. And here, let's just do it based off of the app category and block everything in the streaming category. All right. Next, let's look at an application-based policy for Teams. And finally, let's build our allow all. All right, so we've got all of our all of our classes made. Now let's string them together into a policy and assign those actions. So this is port access application-based policy. We're going to call it contractor because that's the role we're going to apply it to. But you could use any naming convention that you want, and these policies could be applied to multiple roles. So we're going to tell it, the first is classifier, application-based policy of retail, and the action is going to be drop. 20 is going to be the classifier streaming. Action is also going to be drop. The third one is going to be our Teams, and the action is going to be DSCP remarking to expedited forwarding. And then 40, we're going to do a class, and we called it allow all, and we're just going to permit that one. All right, so we've got the policy built now. We've got to assign that to a role, and we also have to make sure that that role is associated with a group-based policy role ID, so that the application-based policy can be applied. So first, let's go in and add it to our contractor role. And we're going to associate the application-based policy contractor with this role. All right, and the last step I want to take here is I want to make a group-based policy and match that role, and we're going to assign it to the role ID 100. All right, so we've got our configuration complete, and now what we need to do is make sure that our policy works and that the client is dropping the appropriate traffic. So let's switch back over, log in, and see what kind of traffic we can generate. So I've logged back into my contractor role, and I'm going to go ahead and open up my browser again, and let's try and load up some of those same pages. You'll see we get a pretty quick load there, but this is all cached information. Whenever we start trying to load new pages, that's where we see that the traffic is getting dropped, because that's having to be drawn in. So now let's check a few more. We should still have our socials, that's fine. But we shouldn't be able to get to our streaming sites. Again, we get our preview. But once we start trying to search, we see that our results are again getting dropped. So let's jump back over to the switch and see what's happening with our hit counts. So the command here is show port access ABP contractor hit counts. And here we can see we're getting hits. We first see what our policy is and our sequences. Then in each one of the classifiers, how many hit counts we've gotten. So we saw that the Amazon got 179 hits. Our streaming category got 190. Teams, we didn't have any traffic generated, but then we had 2,100 hits across the application for the allow all. So this concludes our application-based policy tutorial, where we demonstrated how to configure application recognition, an application-based policy, and we demonstrated what it looked like for that to be applied to a client's account, to their user role, and then to have that traffic dropped across the flows. And as always, if you have any questions, please feel free to drop a comment below. And don't forget to like and subscribe to the Airheads broadcast channel for all things Aruba. Thanks!